All right, so what we have here are a number of ionic compounds who we need to figure out their formulas for. We know they're ionic because the first thing written in them are metals or positive ions. Here, this is an example of a polyatomic ion that you can get here from your sheet. So the key with these is to first figure out what the symbols for each of the things that are in this compound are. So for potassium, you look to your periodic table. It's got a symbol of K. Fluoride is just the element fluorine. It's got a symbol F. And then the trick then to figure out what the right formula is to figure out the charges on each of these. And for that, the periodic table will help us for some of them. For some of them, we have to do a little detective work. So for potassium, it's in group 1, and we know elements in group 1 have a positive 1 charge. And fluorine is in group 17, and elements in group 17 have a minus 1 charge. We switch to a smaller, there we go. So what we need to do then is figure out how many of each of these we need to cancel our charges out. We need to have the same amount of positive charge as negative charge. In this case, we've got a plus 1 and a minus 1, so we're good. They cancel out. So my formula would just be KF. I want to go back to the bigger one. Just potassium fluoride there. Now here, this one's a little bit different in that it contains not just elements from the periodic table, but elements acting together as one particular ion. So this is ammonium sulfate. You could look all day on the periodic table to find ammonium, and you won't find it. So you look to your sheet of common ions, and you find that ammonium has a symbol of NH4, and it also has a positive 1 charge. So that all 5 of those atoms there contribute to get a plus 1 charge. Sulfate is also a polyatomic ion, and it has a formula of SO4, and it has a minus 2 charge. Now we're not going to get away with just one of each of these to balance it out because we'd have a leftover negative charge. So the trick then is to take our charges and use them as our subscripts for whatever it is that we're binding to. In this case, sulfate's going to bind to ammonium, and ammonium is going to bind to sulfate. So we're going to take sulfate's charge, just the 2, not the negative sign, and use that as the subscript for ammonium. So let me switch back to blue and show you what this would look like. Now that 4 in ammonium is part of what makes ammonium ammonium, so we can't touch that. So if we need 2 of them, we're just going to have to place this in parentheses with the 2 outside. And then we can't forget about the sulfate. And that's what our formula will look like. We only need 1 of these because of the 1 up here. Magnesium iodide, going back a little bit easier. Magnesium is just Mg. It's in group 2, so it's got a plus 2 charge. And iodine is group 17, just like fluorine. It's got a minus 1 charge. We're just going to crisscross our charges. So we're going to take this 1 and use it as a subscript for magnesium. Although we don't generally write 1 as a subscript, so we're just going to leave it as Mg. And then we're going to take the 2, that's the charge for magnesium, and use it as a subscript for iodine. Down here we get a little bit different here. We've got a Roman numeral here, and that's because copper is a transition metal. It's a metal that's kind of in the valley of mystery. We don't know what its charge is based on its location on the periodic table. Luckily for us, this Roman numeral tells us that copper's charge is plus 2. Sulfite is a polyatomic ion, that's SO3 with a minus 2 charge. We could cross our charges and find that we need 2 coppers and 2 sulfites, but we notice that our plus 2 and our minus 2 will cancel out, so our formula should just be CuSO3. Aluminum sulfate, same deal. Aluminum's in group 13, so it's got a plus 3 charge. Phosphate is a polyatomic ion with a minus 3 charge, and if you notice, our charges are going to cancel out here, so we're just going to end up with AlPO4. This one down here, lead, a little bit similar to the copper one up here. Lead is Pb. We know the charge of lead is plus 2, and nitrite is NO2 with a minus 1 charge. So here we're going to have to crisscross these charges. We're just going to get a Pb, just one of them, and we're going to need 2 nitrites. Because of this 2 up here, we need 2 of these to balance out. We need 2 of these to balance out our positive 2 charge.